Okay, so we're going to talk about how to use scale change mappings to make new equations. So the first thing we have is that our scale change is x divided by 3 and 2y. So we're going to describe what happens to our x values and our y values first. So because x is being divided by 3, that's the same thing as multiplying by 1/3. So what we're going to do is we're going to say that that is a horizontal shrink of 1/3 because it is less than 1. And because y is being multiplied by 2, it's doubling, we can say we have a vertical stretch of 2. Okay, so now we've described in words what's happening. So now we're going to come up with a new equation. So just like with translation mappings, when you go to the equations, you do the opposite of what you see. Same thing with scale change mappings. So when you see, for instance, if our scale change mapping is s of x comma y is equal to a times x by, you're going to replace, in your function, you're going to replace x with x divided by a, and y with y divided by b. So the opposite of what it sees. So if the scale change mapping starts with multiplication, you then input with division, and if it started with division, you would input in with multiplication. So now for our problem, we have s of x, y, just rewriting our scale change, is x divided by 3 and 2 times y. So that tells us to replace with the opposite in our equation. So since we were dividing x by 3 before, we're going to replace with the opposite, which is multiplying x by 3. And y was being multiplied by 2 in the mapping, which means that we replace with the opposite, which is dividing it by 2. So now we go and actually substitute into our equation. So our original equation was y equals the absolute value of x. So now we have y over 2 equals the absolute value of 3 times x. And now, of course, you want to solve for y. So this is our substitution, our replacement step still, and now we're solving for y. So to do that, we would multiply both sides by 2 to cancel the dividing by 2, and we would be left with y equals 2 times the absolute value of 3x. So that's our final answer for changing the equation. And now, of course, we want to graph it. So we're going to make a t-chart of values, and we're going to graph both the parent function and the image function. So our parent function was y equals the absolute value of x. And so we're going to make our t-chart. So I'm going to pick the values -6, -3, 0, 3, and 6. And you'll see why I picked those in a second. So of course, taking the absolute value, we get 6, 3, 0, 3, and 6. So now we're going to go over to our graph, and we're just going to plot our points. We have 0, 0, 3, 3, and 6, 6. And then same thing on the other side. So -3, 3, and -6. 6. It's right there. Then I'm going to use my straight line tool to connect the dots so we can see our full function here. So there's one branch of our absolute value and 2 branches. Okay. So now we're going to plug in to our mapping. So we have x divided by 3 and 2y. So we're just going to take our original points and use our mapping to transform them, because that's the easiest way to do this. So if I do -6 divided by 3, I get -2. -3 divided by 3 is -1. 0 divided by 3, 0. 3 divided by 3, 1. And then 2, 6 divided by 3. And then we multiply their corresponding y values by 2. So we get 12, 6, 0, 6, and 12. So now we're just going to plot our new points. So we have 0, 0, and then the point 1, 6. So we have 1, 2, 3, 4, 5, 6. Same thing with the -1, and then 2 and -2 are at 12, which is off of our graph, so we're going to have to approximate a little bit. So we go to 2, and then a little above, and same thing on the negative side. And then we're just going to use our straight line tool again and connect the dots to form that V shape. And there you go. There is our new graph there. Y equals 2 times the absolute value of 3x. Okay, so let's do another example just to make sure we have it under our belt. So now we're going to use the parent graph y equals x squared, and we're going to transform it with 4x and y over 6. So we want to write the new equation and we want to do the graph. So let's start off with doing our equation first. So step 1 is to find our replacements, so our substitutions. So remember, we replace with the opposite. So if we were multiplying x by 4 in the mapping, it means we replace in the equation with dividing by 4. And if we have y divided by 6 in the mapping, it means that we're going to replace with the opposite, which is 6 times y. So now we're actually going to go and do our replacement into the equation. So our equation is going to go from y equals x squared to 6y times, whoops, back that up, I forgot the equal sign, equals, and then when you plug in for x, you're going to do x over 4, and the square is applying to all of that. So now we want to simplify it, so this would be a good thing for that step. So in step 3 is going to be simplify and solve for y. Okay, so we have 6y then is going to be equal to, if we apply the square, we're going to get x squared over 16. And now we're going to want to divide both sides by 6 or multiply by 1 over 6 to get rid of the 6 on the left-hand side with y, which is going to leave us with, going over here, y equals x squared over 96, if I did my math correct. Okay, so that's our new equation, and now we're going to graph it. So we're going to set up a t-chart for our original, and then we'll set up our t-chart for the parent graph. So let's see, let's do our regular numbers. Let's do -2, -1, 0, 1, and 2. If we plug in, we're going to get 4, 1, 0, 1, and 4. So go ahead and plot our parabola. Then I'm just going to add a couple more points to make my graph a little bit more accurate. Okay, so now we're going to do our new graph in blue. So we have 4x and y over 6. Okay, so multiplying the x's first, we get -8, -4, 0, 4, and 8. And dividing by 6, we get 4 over 6, which is 2/3, 1 over 6, 0, 1 over 6, and 2/3. So these are going to be a little hard to graph, but that's okay. We can handle it. So let's see. We have 0, 0 on the graph still. And then we have -8, 2/3. So going out here to -8 and then up this way. Same thing at +8. And then at 4 and -4, we are at 1/6. So that's really close to the x-axis. So this parabola is very wide. It almost doesn't even look like a parabola because of the scale of our graph. So there you go. So you have one problem to do by yourself now. So on your worksheet, you want to go ahead and look at this problem. You're going to use the parent function y equals x cubed, and you are going to do 2 different transformations. So you're going to do the A transformation and the B transformation and find the new equations. So hopefully this made sense. If not, please bring your questions to class tomorrow.